Hello everyone, I'm Ali from TU Delft and I'm happy to be here today presenting for you our published paper by Empirical Software Engineering Journal in 2025 August. The title is Exploring the Black Box, Analyzing Explainable AI Challenges, and let's start quickly. Explainable AI helps us understand the decision AI systems make. Since 2018, GDPR has pushed explainability into the center of AI discussions. The statement is every decision making system should be able to explain the decision it makes. This figure shows a clear upward trend. XAI is getting more attention over time, especially since 2018, the GDPR effect, which reflects its growing importance in both research, practice, and also politics. Moving toward XAI is important and getting more attention, but what are the challenges? If we understand where developers struggle, we can design more effective tools, improve explanation quality, and make XAI easier to adopt. We have 5 research questions. We have research question number 1 for the topics or the challenge, research question number 2 for what kind of questions are XAI developers asking. Research question number 3 goes for popularity and difficulty of the topics. Research question number 4 is about technologies and XAI package. Research question number 5 is asking how do the XAI topics evolve over time. Our methodology has 3 main steps. First, we collected XAI related posts from 3 Stack Exchange communities, Stack Overflow, Data Science, and Artificial Intelligence Forum. And after pre-processing, our reduced data set contains 999 posts. In the second step, we used LDA topic modeling to identify 10 topics. In the third step, through manual analysis, the 10 topics identified by LDA were then labeled manually. And again, through manual analysis, those 10 topics were grouped into 6 higher level categories and further refined into subtopics. But in this presentation, we are not going after subtopics. Research question number 1, the results. What topics are XAI developers asking about? So if we look at the big picture, troubleshooting clearly dominates the discussion, which tells us that developers often struggle with using and integrating XAI tools in practice. Feature interpretation comes next, followed by visualization and model analysis. Then we have concepts and application and data management in the end. So even at this high level categories, the emphasis is very practical. Troubleshooting, I mentioned, is the largest category, and this example illustrates a typical implementation issue, such as tool usage or runtime errors. The second major category is feature interpretation. This means developers are trying to understand how features influence model behavior and predictions. This example shows a typical question of that kind actually. And category number 3, visualization. These questions focus on how to present or visualize explanation in a clear and effective way with plots. And this is a typical question about plotting with Python. And category number 4 is about model analysis. So here developers are not just trying to use the tool. They are really trying to understand what the model is doing, how to improve it, and whether the explanation method actually makes sense or not. In this example, the question is basically, does this faithfulness score really reflect the model's reasoning or not? Category number 5 is about concepts and applications. Here developers are asking more foundational questions. For example, what terms like interpretability, transparency, and explainability actually mean, and how do they differ from each other in practice, like this question that you are seeing here, this example. And finally, data management. The focus is on getting the data into the right shape for XAI. Things like pre-processing, interpreting data correctly, dealing with incompatible formats, or handling large data sets. And here in this example, you are seeing the question is whether the SHAP background dataset should be standardized or not. So first, the LDA analyze. First LDA analysis identified 10 topics for us. Then through manual analysis and discussions among the authors, these were grouped into 6 higher level categories. So here, for example, you are seeing troubleshooting contains 3 topics: tool troubleshooting, model barriers, and SHAP programming error. Feature interpretation contains feature importance and SHAP values. Visualization stands for its own. Model analysis contain model improvements and neural network interpretation. And concepts and applications and data management, these 2 stands for themselves. So in the left we have the categories, and overall you are seeing the 10 topics. What kind of questions XAI developers are asking? We ask the question because understanding the type of questions developers ask helps us understand the kind of support they need. It tells us whether the main need is practical guidance, conceptual clarification, debugging help, or something else. We have different kind of categories here. The first category is how questions. The how category is basically about practice. Developers are asking how to implement something, how to use a method, or how to solve a difficult task. This is a very typical how question. The developer is not asking about definitions or theory, but about how to actually use Lime, a XAI package with a specific model in practice. Why questions, this is another category, are about understanding why something is happening, especially when the model or the explanation behaves in an unexpected way, actually. And this is a very typical question: why does SHAP behave this way? What questions are more about what something means, what it is, or what the right interpretation could be? You're seeing here an example. What is the difference between key XAI concepts? And of course, we have a category for other type of questions. And this is a result. The majority of the questions are practical implementations, standing for how questions. Then we have why questions, which are more into reasons behind a behavior. Then we have what questions, which are more into conceptual and understanding questions. And we have a little amount of other type of questions. What's interesting here is that not all categories look the same. Concepts and applications is more about what and why. So understanding concepts and reasons, and they are into foundational questions. On the other hand, other categories are mostly into how questions, which tells us they are more practical. Research question number 3, popularity and difficulty of the topics. Before looking at the results, we first define popularity. Here, popularity is measured through number of views, number of scores, number of comments, and then we combined them into a single metric called fused popularity. We see that concepts and application attract the most attention, followed closely by tool troubleshooting and neural network interpretation. In contrast, feature importance appears to receive the least attention among the 10 topics. Let's go after difficulty. Difficulty here is measured through number of unanswered questions among a topic and time to get accepted answer. And we summarize these 2 into fused difficulty. And this is the ranking. Model improvement is the most difficult topic, followed by model barriers and SHAP values analysis, while feature importance is the least difficult. This slide brings popularity and difficulty together, actually. So the top left area highlights topics that are difficult but attract less attention, such as model improvement and model barriers. In contrast, the bottom right area contains topics that are both popular and relatively less difficult, such as tools troubleshooting, SHAP programming error, neural networks interpretation and concepts and applications. Some topics like shape values analysis and visualization are not only popular but also difficult. Others like feature importance and data management attract less attention and are also relatively less difficult. So this helps us distinguishing high demand, high friction topics from low demand and low friction topics. Let's go for technologies. SHAP is dominating the field. Then we have Lime, Yellowbrick, LE5, Daleks, and AIF 360. Python is also dominating the field and R is following. This slide moves from topics to tools. It shows that SHAP is the most popular package in practice, LE5 and Yellowbrick following behind, and at the same time difficulty is not the same as popularity. Daleks appears as the most difficult package. On the other hand, Yellowbrick, LE5 and SHAP are relatively less difficult. So SHAP stands out because it is both popular and relatively manageable to use. LE5 stands out as both popular and relatively easy to use, and Yellowbrick is notable for sure for combining relatively high popularity with the lowest difficulty. Research question number 5: how do the XI topics evolve over time? Interest starts to grow around 2018 at the same time with GDPR, with troubleshooting leading the way. And later, we also see increasing attention to feature interpretation, model analysis, and visualization. The foundational questions are always there with the same amount of questions, but the majority of the questions overall over time are practical challenges, or about practical challenges. This slide shows how the use of different XI package changed over time. These results are from GitHub about the package. SHAP clearly becomes the dominant package, especially in the later period. Lime appears earlier and stays consistently used, while LE5 and Yellowbrick also gain attention, especially Yellowbrick, but not at the same scale of SHAP. But what do we learn from the implications? XI challenges are not only algorithmic. Software engineering matters here. Tool usability, compatibility, education, and user experience are very important. So for the developers, the takeaway is that many current barriers are very practical. Better usability, better documentation, and better compatibility would make XI tools much easier to adopt in real settings. For educators, the takeaway is that theory alone is not enough. Students also need hands-on practice with XI tools and visualization to understand how these methods work in real settings. And for researchers, it is not enough to just proposing another XI method or another mathematical algorithm. The bigger need is for tools that work well in practice, fit into real systems, and actually help users. So let's go for best practices. We summarize best practices across the XI life cycle. In the design phase, the key message here is to start with data itself. That means paying attention to the data quality, checking fairness early, and being transparent about possible limitations or bias in your data. So in the development phase, it is not just about picking a tool and getting the results. It is also about matching the tool to the task and checking both model performance and explanation quality. Deployment. And in deployment, do not treat XAI only as an internal developer tool for debugging the models, and also use it to produce explanations that real users can understand and benefit from. This really fits and refer to the famous statement of GDPR 2018. Let's count on the understanding of the users and users also, not only the developers. In the end, XA adoption depends not only on better methods, but also on better tools, better workflows, and better support for developers and users. Thanks for your attention. And you can use the QR code to download our paper. I'm also here for your questions.